going to talk about graphs that are like x to the third power. If you have the square root of x, all of those things, we're going to talk about how to graph them. But once we understand the transformations, no matter what the exponent is, you're going to be able to graph all of them, okay? So we have to really understand what's going on. We're not going to use a calculator, all right? We're going to use the absolute value function as an example. So over here, let's first, let's do some examples. We've already been talking about these, 1 through 7. So when the absolute value, let's go ahead and write our parent function, f of x equals the absolute value of x. So this was the original parent function. Remember, it started at 0. So go ahead and draw your parent function there. Started at 0, goes up 1, over 1, up 1, over 1.
On both sides.
Yep, on both sides. I like to say up 1, out 1, because it's going to go out on both ways. So if you look at number 1, it says the absolute value of x plus 2. But what do we have to be careful about? First of all, is this a horizontal shift or a vertical shift?
Horizontal.
This is going to be a horizontal shift. Okay, so let's write that there.
How do you know that?
Because if it's, remember, if it's on the inside of the parentheses or on the inside of the absolute value, it's always going to be the horizontal shift.
What's on the inside?
The number. So do you see how the 2 is on the inside? Okay, so this is a horizontal shift. But what do we have to remember about the sign here?
It changes.
So this is actually a horizontal shift of negative 2. Good. What about number 2? What kind of a shift would that be? Horizontal. Okay, positive 2. Which way? Horizontal or vertical? Because it's inside, right? So a horizontal shift. Yep, horiz shift of positive 2. So if we look over here on our second page, this f of x plus h just means no matter what the function is, if you have a plus h, okay, no matter what that number is on the inside, whether it's to the cube power, whether it's squared, what is a number on the inside of the parentheses going to do? Horizontal shift, right? So we know if there's a number on the inside of the parentheses, it's a horizontal shift. So we're going to write that. Horizontal shift. If it's on the inside of the parentheses. But if it's a plus, Mitchell, what were you saying? We're actually doing the opposite, right? So we would think plus is going to go to the right, but really plus takes us where? To the left. So horizontal shift to the left.
I just thought of something. If there's an exponent in there on the h value...
It won't be. It'll be on the outside of the parentheses.
Oh, okay. I was going to say...
Okay, Leanna, go ahead. What about the next one?
It's going to have a horizontal shift to the right.
Horizontal shift to the right. If the number is negative, looking to be negative, on the inside. All right, so let's go back over here to example 3. I have the absolute value of x plus 2. So when 2 is on the outside, it's a vertical shift. And what am I doing? Where am I going? Am I going the same direction?
It's going plus 2 because it don't change. It's on the outside.
Right. It does. The sign does not change for your vertical shift. So this is a vertical shift of positive 2. The sign does not change for the vertical shifts. So then number 4 is going to be a vertical shift of, the sign does not change, Ashley, right? Of negative 2.
I was testing you.
Oh, thank you. I need that. I haven't had a math test in so long, so yes, thank you. Okay, so now let's look over on the right side of the page. They have the f of x, they've closed off the parenthesis, right? So that plus K on the outside is a what kind of shift? Vertical shift. Listen, you guys are going to nail this. You're not going to have any problems with this. It's a vertical shift. In which direction are we going if it's positive? Vertical is not right and left. Vertical is up and down. So if it's positive, we're going up.
Would it be proper to say of a positive value, or would that be
Let's just say up, because that's going to make more sense to you. Okay, and then if it's a negative K, it's a vertical shift down. This page is going to be a lifesaver for you. Okay, so that's why we're filling this out. Okay, number 5. So number 5, that 2 is where?
Outside.
It's on the outside. It represents the, what did we say it was? Slope. It's not technically the slope, but it's a good way for us to understand that. That tells us whether the graph gets skinny or large. So if I'm going up 2 and over 1, up 2 and over 1, is my graph getting skinnier or wider? So we were going up 1 over 1, up 1 over 1. Now I'm going up 2 and over 1, up 2 and over 1. So it's getting skinnier, right? So we call this a dilation. You'll learn this in geometry, right, Lexi and John Braxton? Oh, and Ben. Dilation, and it's getting skinnier, because that's an official math term. No, I'm just giving you a hard time.
Who said she didn't have a sense of humor?
I know, it rarely ever comes out, but it's there. Okay, so this number 2 is greater than 1, right? 2 is greater than 1. So over here when it says the dilation, if you have A times something, if A is greater than 1, we know it's going to actually be skinnier. And then what about 1 over 2, right? So if I go up 1 and out 2, up 1 and out 2, I'm getting fatter or wider, if we want to be politically correct. So this is a dilation, and it's getting wider. So, and would you guys agree that 1/2 is smaller or less than 1, right? 1/2 is less than 1. So if it's a fraction, that's a way I like to think about it, but you could have a negative fraction. If it's a fraction, then it's going to be wider.
But they all kind of turn into it. I mean, not really.
Yeah, okay, you're right.
But like,
You're
but
correct.
Like that, like
2 over
number
1, we can
6
say.
is the actual fraction, 1 over 2.
Yes.
And the next 5 is just like 2.
It's a whole number that we created 2 over 1, right? Because 2 over 1 is still a whole number. Okay, the last thing is what happens when it's a negative sign? What does it do? It flips upside down, right? So a negative sign flips it. Flips it upside down. The official term for that is called a reflection. So over here where it says negative f of x, you can just write it flips it upside down. Flips the graph upside down. Okay, we need to talk about just a couple things before we do that next page. So if you go back to page 22, we know that a quadratic graph looks like what? It's a U, thank you. And it goes in the form f of x, that same thing. The actual shape is called a parabola, but a quadratic is when it's x squared. Okay, and we know x squared starts, we're just going to start it at 0, and we know that this one's going to open up. This is what a parent graph looks like. We're not going to worry about what's over here in this box. Okay? The absolute value graph looks like f of x equals the absolute value of x. What shape is that? The absolute value is what shape, Ben?
V.
A V. Good. Okay, the next one is a square root graph. Ooh, we haven't seen these next two. Okay?
I don't think I want to.
Yeah, you do. It's no big deal. The square root graph looks like this. F of x equals the square root of x. Oh my gosh! Yes! So let's do this. Let's just pick 2 points. If my x value was 4, and I plugged it in for x, what's the square root of 4? 2. The y value would be 2. So the graph 4, 2 would be here. What about if my x value was 1? And I put the square root in, is what? 1. So the square root graph looks like this. And remember, yep, that's all that the square root graph is. Put that there. I'll show you. I'll explain it to you.
Oh, that's just
Up one, the points 2 and 3 are not whole number points, okay? So we know for sure we have the point 1, 1, and we have the point 4, 2 for sure. The other ones are kind of in the middle. Because guys, can you take the square root of a negative number? You get imaginary numbers, right? So you can't put a negative number in here for x because you can't take the square root of it. So all of these numbers right here are off limits, right? And if you're always taking the square root of a positive number, your answer is going to be what? Positive. So that eliminates all these values down here. That's why your graph only comes over in this quadrant, okay? All right, now the cubic graph. Cube is how many exponents?
3.
So this is x cubed. The x cubed graph, what happens if my x value was 2? What is 2 cubed? 8, right? Actually, yep, let's do that. What about 1? What is 1 cubed?
1.
So I have the point 1, 1 for sure. 1, 1. And then I have the point 2, 8. Okay. What about 0? What is 0 cubed? Okay, so go through the point 0. What about this, though? What if I continued my chart? What if I did negative 1 cubed? So what is negative 1 times negative 1? No. Positive 1 times negative 1. So now I have the point negative 1, negative 1.
So a cube would go negative?
Because we're not taking the cube root, we're just see. Okay. What about negative 2 if I plug that in for x? If I plug negative 2 in here for x. What is negative 2 times negative 2? 4 times a negative 2, negative 8. So I'm at the point negative 2, negative 8. So your x cubed graph looks like a little snake. That's new to us. It's not the end of the world. You're in Algebra 2, so we're taking it up a notch. Notice that it goes through 0, 0, okay? Because that's what's going to shift. So if I told you, I want to check this problem out. Let's, if you have another color marker, that would be great. If not, it's not a big deal. If I told you f of x equals x cubed plus 4, okay? F of x equals x cubed plus 4. The plus 4 is a what kind of shift now? It's on the outside.
It's vertical.
It's a vertical shift, right? If it was horizontal, it would be inside of parentheses with cube. If it's on the outside, it's a vertical shift of how many? 4. So this is the point, this purple dot right here, this is the point that's going to move. So I'm shifting that up to 4. 1, 2, 3, 4. And now this is what my snake would look like. I just took the middle and moved it up 4. Okay, so that's how you shift a cubit. All right, so we're going to practice that. You're going to be fine.
Is it at all